All right. Let's do it. A polynomial is defined by p of x equals blah, blah, blah. Show that p of 3, p dash of 3, p double dash of 3 is equal to 0. Easy. You're just obviously going to sub in 3, which equals 0. P dash of x becomes 4x cubed minus 21x squared plus 18x plus 27. Sub in 0. So.
Sorry, Sam, can you send this as a PDF, please?
Yes, I'll do that now.
Thank you.
Not subbing 0, subbing 3 is what I was meant to say. 3 cubed minus 21. And that should equal to 0. P double dash of x becomes 12x squared minus 42x plus 18. Subbing 3 into that as well. P double dash 3. And that should give you 0 as well. Find all roots and their multiplicities. Okay, what does this mean if we found that the first derivative, so the polynomial, the first derivative and the second derivative have roots at x equals 3? What does that mean at x equals 3? So what would you say about x minus 3? What power would that have? What's their multiplicity? What's its multiplicity? X minus 3 to the power of what? So if the original polynomial, the first derivative and the second derivative all equals to 0, what power would this be up to? 3. So its original would be 1. Second derivative, our first derivative would be power of 2, so it has a double root. And then if the second derivative works as well, it's got a triple root. Triple root, which means x minus 3 cubed. Yeah. And then find all the roots and their multiplicity. So, okay, how would you guys do B now? Now that you know, I guess 3 roots are 3. How would you have gone and found the fourth root? The last root? Because there's a lot of ways. So what would you guys have done? Give me some ideas.
Polynomial division, but like, yeah.
Poly division. Yep. With what being your factor, like this one here?
Expand. Yeah, you divide everything by that. Yeah.
Expand. Yeah. Okay. Yep. Anybody else? Because that's the way you've usually done it. But yeah, anybody else? Another way, another technique, another method? No? Maybe you haven't linked it together just yet, but you guys know that the roots are 3, 3, 3, and alpha. Just like you could have said alpha, beta, gamma, delta, the roots are 3, 3, 3, and alpha. So therefore, I'm just going to do sum of roots. Sum of roots one at a time is just 3 plus 3 plus 3 plus alpha equals minus b on a, which is 7. Therefore, alpha equals 7 take away 9. That's a lot quicker, right, Ben?
Yeah, it is.
So you've just got to start linking your polynomials together, I guess. Because usually the way you guys have done this technique has been only with alpha, beta, gammas, and deltas. You haven't really linked it that alpha and beta are just roots, and roots are just your factors, and then so on, and polynomial division. So it's all kind of part of the same thing. Hopefully soon. There you go. Nice and simple. That's what I would have done. Any questions before I move on? Let's go again. Find the exact value of cos 45, cos 15. I'm pretty sure that's part of your formula sheet. Here's your formula sheet here. Yes, it is. Cos 45, cos 15. Which one? Obviously, it's going to be this one here. Cos 45, cos 15, which is a half, cos A minus B plus cos A plus B. So half cos A minus B, cos A plus B. Half cos A minus B plus cos A plus B. Is that what it was? Yes, I think so. Minus B plus, yep, perfect. All right, and that's it. Obviously, A is 45 minus 15, which is 30, plus 45 plus 15, which is 60. Plug it into your calculator. Cos 30 should give you root 3 on 2. Cos 60 should get you a half. And your answer should become root 3 plus 1 on 2 times 2, which is 4. Yep. All right, find the exact value of tan 45, tan 15. That shouldn't be a formula, but let's double check it in case you thought it would be. Tan, there's only sine and cos. So what do you think the logic's going to be for tan?
T formula?
Ooh, nah.
Would it be? Oh, okay. Never mind.
I think overkill. Overkill.
Okay. All right.
Maybe I'll go back up real quick. But I like it. Yeah, at least you're giving answers. It's good. So just look at the I guess look at the part A and the relation to part B, what it's the same, and then think about it, and you can probably get it out. What do we think I'm going to do to find tan? 45, tan 15. You did say T formula. Look, just so you're aware of this, I don't see why your T formula wouldn't have worked. It's not a hence question, right? If it was hence, you definitely have to use A. But your T formula would have worked because you would have let T equal to tan theta on 2, and then theta is going to be 30 degrees, and that will give you tan 15. Was that your logic?
Yeah.
Yeah, that kind of, it would work. I'm not going to take that away from you. But I think they're trying to make you guys realize something here. What do you think that is? Tan. The angles are the same. Think of tan. What are you going to use? What are you going to find first? Trust me, you guys are overthinking it. Tan. Come on.
I'm thinking sine on cos, but I don't know how that links back.
Well, how can it not? If I had sine 45, sine 15 on cos 45, cos 15. What's that? Well, isn't sine 45 on cos 45?
I see it. Okay.
Of course it's that. So you don't have tan because you can get tan from sine and cos.
Yeah, okay. Cool. That makes sense.
Yeah, so all you got to do is get sine 45, sine 15, which should be the same as the formula that we've got here, except minus. Let's double check. There it is, sine, should get you minus, yep. So that should get you half cos 30 minus cos 60. And then that becomes root 3 on 2 minus a half. Root 3 minus 1 on 2, which is 4. And then literally just going to divide. So root 3 minus 1 on 4 divided by root 3 plus 1 on 4. This will cancel out. Your answer is root 3 minus 1 on root 3 plus 1. I guess that's exact. I don't really say simplified answer, but let's just do it anyways. This becomes 3 minus 2 root 3 plus 1 on 3 minus 1, which is 2. 3 plus 1 is 4. 4 take away should become 2 minus root 3. We can double check it real quick. Tan 15 is 0.26. 2 minus root 3 is 0.26. You guys might remember we did a different, we did a pretty much the exact question, but in a different way just last week with the other exam paper. So look at that. That's a different way, and obviously T formula would be another way as well. I guess, Ben, the way I think about it is there's always a reason for part A or part I if there's a double I or part B. So you've just got to learn to find the links. Any questions? Aya, that makes sense? Everything I've done there?
Yeah.
Cool. Did you think of that? Did you think of tan is sine on cos?
At first, no. But
Yeah.
then,
Yeah. Tan theta is sine theta on cos theta, so you can do that. Cool. Let's try another one. Rates of change. Starting from a point 0, a particle P moves due north such that its displacement in meters from O is given by y equals 40t, where t is in seconds. Also starting from O, a particle Q moves due east such that its displacement from O is given by x equals t squared. Let r be the distance between the two particles at time t. Let r be the distance. Okay, cool. Find the rate at which r is changing. So pretty much find dr on dt. How are we going to do it? How are we going to find dr on dt? Any ideas? No ideas at all. Well, I would at least say it's dr on something times something on dt. I would at least get that far. Then I'll be like, well, I don't know. Let's say if I did this one as dx, this one as dx. And then I'm like, well, dx on dt, I know it can be written as 2t. The r on dx I don't have. I don't have a relationship between r and x. But can I get a relationship between r and x? Let r be the distance between the two particles at time t. So what would the radius be here? What would what would radius? What would r be here? What would r be here? Isn't r equal to? You can probably do it even faster. Isn't r equal to the hypotenuse? So you could do it as x squared plus y squared. I just realized you could just do it like this, which would probably save you a bit of time, and you probably wouldn't need this splitting up. That doesn't matter. Square root x squared, so that becomes t to the power of 4 plus y squared. Y squared is 40. 40 squared t squared. So in this case, you probably don't even need dr on dt as a chain rule question, because what you can do is you can find r with respect to time, and then you're just going to differentiate it. So it's even easier than this. If you wanted to continue this way, you need an expression with r and x only. So what you would have to do is, so I'll just show you guys, r and x, right? So you've got r equals x squared plus y squared. I've got to make y in terms of x's. And the way you would do that is, you know that y in terms of x's. Wait, other way. Y in x, you're going to make t the subject. So t equals to y on 40, and then you could sub it in here. And then you'll make y squared as 40 squared x. You'll sub that in, and then you have r's with x's. But instead of doing that, we can avoid all these complications. But I just showed you can do this. That will never fail you. But we probably can make it a little bit easier, because now that we know that r is equal to square root of x squared plus y squared, x squared is t4, y squared is 40 squared t squared, we can just get dr on dt by differentiating this, which would be half, and t to the power 4 plus 1600 t squared, power of negative half, times 4t cubed plus 3200t, derivative of the inside, when t equals to 4. Now you just sub in 4. Does that make sense? Or did I lose some of you guys with the change here?
Wait, yes, we don't have to do that all the way.
Well, you don't need to, in this